Hey, good evening, everyone. So nice to see all of you again. Glad that you can join us tonight. So, yeah, my name is, oops, oh, that looks funny. My name, let me just fix that. Pardon the, okay. So, yeah, my name is Roland. I'm your host tonight, and I have a special guest with me, Adrian. So let's go over to Adrian. Sorry, where are you, Adrian? Okay, there you go.
Hey everyone, so glad to join today. One of the other mentors in Game of Apps, been a mentor since season 1, so it's a fun way to see some more ways that we can teach some programming. Respect to you, Roland.
All right. So yeah, great to have you with us today, Adrian. So let's see who in the audience, if anyone cares to say hi. Tell us, I guess, what city you're from, and whether you're in high school or elementary school. Just type it in the chat, and we can greet you and welcome you tonight. So feel free to do that. As always, we want to make this session this evening quite interactive. So we want to hear from you. We want to hear your thoughts and questions and anything, any ideas that you might have regarding the game that we're building. So please feel free to put in your chat. So yeah, again, if this is the first time you're joining us, please say hi on the chat and we can welcome you. So yeah, this is our third episode, and what we're doing. Oh, So William just finished high school. Welcome, William. Nice to see you again. Welcome. So yeah, just a quick background. This is our third session of the Let's Build an App series. And what we're doing is we're building an app from scratch, and we're building a game. So we've built we're building it in stages. Every week at the end of the session, we give you access to the source code in GitHub, so you can download it. And if you have a Mac and Xcode, you can actually run it on your computer. And we also give you access as a beta tester. You can download the app on TestFlight and install it on your own iOS device. So yeah, I know that a number of you have already taken advantage of that. So hopefully you've been testing. I think William, you're one of the people who's in the beta testing with TestFlight. Have you been able to run the what we have so far, and any thoughts or feedback from what you've seen? William says, yeah, it's pretty cool. Okay, awesome. Thanks, William. Any others, if you have any feedback or you want to introduce yourself, please do so over the chat as well. So Adrian, I don't know if you've been following along with some of the stuff that we've built so far. Any thoughts on the game so far? So the game, for a quick review, is you're an air traffic controller and you're controlling an airspace. You have planes inside your airspace that needs to go somewhere. And then your job is to direct them to where their destination is while avoiding any mid-air collisions with other planes. So that's basically it. Any thoughts, Adrian, on what this concept is?
Yeah, I've been paying a bit of attention to see what you guys have been doing. I think think about a lot of games. It's like even having released can make some pretty fun games. You see it a lot in the industry nowadays, all these like indie developers, and it's a nice and simple concept to show how you could go about building games. I guess one other thing that's kind of interesting is it's been going on 5 years now since Game of Apps started, and now we can finally get around to the students asking, oh, how do you build games? So we're showing it finally.
That's right.
Yeah.
That's right. I guess it is an unfortunate selection of name, People think when they look at Game of Apps that we're going to teach them how to write games, but we're actually just teaching them we're teaching students how to develop an app, not necessarily games.
Yeah.
Yeah. Okay. So one thing that I noticed too, so the audience, if you see any weaknesses in kind of what we're building, let us know too. As I've been looking through this, I realized that our graphics is really bad. And I tell everyone that I'm a developer. I'm not a designer, so I don't draw very well, and I don't have the eye for what looks good. But I was just looking at our graphics, and it looks pretty bad. So what I want to do is, before we finish off this app, we're probably gonna redraw some of the assets, right? So we'll have a better looking plane, maybe a better looking runway or something like that, right? So that's something that we want to do.
I don't know if you've seen, some professional game developers on their first prototypes and stuff. The graphics and the assets look pretty crappy, but the important thing is getting that first, prototype of the door showing the mechanics.
Yeah, that's right. Getting things working. Yeah, at least for me, anyway, right? I want to be able to get things working, and then at the end, I can just swap out the images, and then we can have better looking images. So as I mentioned in the promo for tonight's episode, what we've done this week is that we have refactored some of our code to start using the Sprite Kit framework in iOS. So the first 2 weeks, what we did was we built our plane. We built our game, or at least the first stages of the game, just using normal iOS UI kit components. So like the plane was basically just a UI button, and we chose a UI button because you can tap on it, and we can detect just those tap events. But it's actually probably not the best way to represent a plane, because a button is meant to be static. And yeah, even though we can animate it, and we showed that the last week we were able to animate the button, it's not that's not what it's meant for. So in the iOS frameworks, they have something called Sprite Kit, which is what we're going to be doing, showing you this week. So we've refactored some of the stuff onto Sprite Kit, and the whole purpose of Sprite Kit is to build games, right? And so we have something called sprites that can move around on your screen, and so this is perfect. The plane should probably be a sprite, right? So it's called a Sprite Node. How many of you know what a sprite is? If some of you have done, anything in the past, and the audience, if you know what a sprite is, let us know in the chat what you know of what a sprite is. Okay, and while you're doing that, I'm going to bring up some documentation. All right, so what I'm showing here is basically the developer documentation for Sprite Kit, and I have a few pages open. So you can see here, Sprite Kit adds high performance 2D content with smooth animations to your app. Creates a game with a high level set of 2D game-based tools. So this is perfect for what we're trying to do. It's a simple game. It's a simple 2D game. And it has the animations, and it can do things like detecting collisions. So we haven't done collisions yet as of last week, right? So with Sprite Kit, it can detect when our planes collide. So that's good. That's what we want to know, right? So, okay, let me just, I'm going to draw just to remind everyone what we're going to be doing. So if this is our game board, what we want is we want to have, let's say there's an airport here. So there's a runway. So pardon my drawing. So there's a runway there, and maybe we have something I'm calling like, these are, I don't know, I'm calling them beacons. So these are our connections to other airspaces. So planes can come in through a beacon. So that means, so let's say there was a plane in some other, imagine there's another airspace here, and say there's a plane that was flying, and it needs to go somewhere. So it's going to eventually come out here. So this is the plane, and maybe it could either want to land on the airport, so maybe it might want to land here, or maybe it wants to continue on its way to this other beacon here, and then your job then is to guide the plane to that beacon so that it can go on its way into the next airspace. Okay, so that's kind of what we want to do. If it wants to land, then what I'm thinking is we'll have another beacon here, and then your job is to guide that plane over to that beacon. And once it gets to that beacon, then the pilot can take over and land the plane. Okay, so that's kind of the game mechanics that I'm thinking. Any thoughts from the audience, or maybe from you, Adrian? Is this okay? Do you want to do something different?
Yeah, it makes sense to me. Just wondering though, is there a reason why the planes would come in only at the beacons and not versus
Anywhere?
Any other point on the edge of the screen?
Okay. I guess I'm thinking if this airspace here to the right, presumably there's some other air traffic controller controlling that space. And if they're doing their job properly, they should have guided the plane to that beacon. That's what I'm thinking. I guess also, I don't know too much about how air traffic control works, but I imagine they have like channels or highways, like air lanes that planes are supposed to be flying on. And I guess I'm thinking this would be like one of these lanes, right? So but I don't know. You think we want to let planes like come in at any point here?
I'm just thinking about it a bit in terms of like how the gameplay is what it's gonna be like.
Yeah.
Because if we have just beacons on the edges, then you're kind of like basically drawing lines between those beacons, right? In some way with the plane crossing it.
Yeah.
It'll work.
Okay. You think it's too simple?
I don't know.
What does the audience think? Let us know while we're discussing this. I guess, I guess if there's 3 beacons, but I guess you still have to avoid other planes, right? So when you draw the paths, it has to avoid the other planes.
How many planes are you expecting to be in play at any one time? Or is that, I guess, maybe would be based on the difficulty or something?
I guess
like
so,
that?
yeah. I'm thinking we have 3 difficulty levels: easy, medium, hard. So maybe the harder levels, you would have more planes in play. Because if let's say this plane is wanting to go to this beacon, and if I guided this plane this way, when it gets here, then I'm thinking that would be the game over, because I lost the plane, like for me, right?
Yeah.
So for every plane that reaches its beacon successfully, I get 1 point. So I keep accumulating points. But if I get a mid-air collision, or if a plane goes out into some random space, then I'm thinking that would be game over too.
Okay. Yeah. I guess the other thing you could do is like you can build it with the beacons first, and then try to see how it plays. And then if you wanted to expand it afterwards, just do that.
We can have them come in outside of the beacons. Yeah. The one thing I was thinking of too is this beacon is both an entry and an exit. So if let's say I had a plane that was about to exit this beacon, and then the game engine randomly creates a new plane coming in here, that's going to force a crash right away, right?
Yeah.
So what I was thinking there is that rather than having a plane appear right away, maybe the beacon would flash red or something, meaning that a plane is about to come in the next 5 seconds or so. Then it allows me to kind of redirect this plane maybe, and then come back. Something like that.
Okay, yeah.
That's what
how are we showing which sort of exit the planes need to go to? Is that could be displayed on the plane itself, or does it matter?
Yeah, so I'm thinking we'll label these beacons. So maybe this beacon A, beacon B, beacon C. So when a plane comes in, somehow it should be labeled where he wants to go. So if there's an A here, then that means that's where he wants to go.
Okay, yeah. You could even probably just do it with like color coding or something like that.
Oh yeah, yeah, yeah. That makes sense too. See, you're a better designer than I am already.
The only thing you'd have to worry about with color coding though is if you worry about like the accessibility of the game.
That's true, yeah.
People with color blindness may have issues with that. So, I mean, the way that I see a lot of game designers get around that, even on board games, is just by having both a symbol and a color associated with something.
Okay, so have both the label A and the color.
Yeah, something like that.
Yeah. Yeah, that makes sense. Okay, yeah. So that's the gameplay so far. I mean, we're refining it, and people in the audience, feel free to provide us your input, either in the chat now, or if you're watching this this video after the live stream, put it in the comments of the video. We'd love to hear from you, and we'd love to have your input. And if you can influence or add your kind of stamp onto this game, that'd be great too. Okay, so let's get back to the documentation. So yeah, so this is Sprite Kit. So we're going to be using Sprite Kit, and there's a few specific classes that we're going to be using. One is called a scene. So this is like the main, I guess, like the main top level class for a lot of the Sprite Kit interactions. You can see here, we won't go through all of this, but you can position things. You can position a camera. We're not going to use that for this simple game, but you can move the camera around. The important thing is that this scene, if some of you have done some iOS coding before, and you have like the life cycle of a view controller, you have like a view did load, view did appear, view did disappear. This scene also has a life cycle. So you can see here, scene did load, did change size, will move. And then, yeah, a whole bunch of other things. So, but this is basically the main, here, there's a physics world. So this physics world is pretty interesting because we can define the physics for this world that we're going to be creating. So some games, they're going to have gravity. So in our case, since we're looking top down,
that was me. I posted a link to the
doc. So I'll put it up to, it's kind of cut off. So, but click on the chat, then you'll see it, because on the screen it got cut off. But yeah, since we're looking top down, then we probably won't be using gravity. But some games where you're kind of looking at it from the side, and then you can have things go up and down. You could turn on gravity. So in our case, we probably won't turn on gravity, but the physics world would allow us to detect things like collisions. So that's really useful for us. The one thing that I want to mention, we won't go over in the code today because it's going to take a little bit of time. But when you do download the code, I want to at least give you a heads up. You see this converting between coordinate systems. So you have two convert point methods here. A convert point from view and a convert point to view. The reason for that is because the coordinate system for UI kit, so the regular iOS coordinate system, the origin 0, 0 is on your top left. But in Scene Kit, and I don't know why they did this, the origin is on the bottom left. Okay, so if you have, as you'll see in our code, like last week we were able to trace the path, right? Trace the path of the plane. We can draw a path, and that's a Bezier curve. But if we took that Bezier curve and we tried to render that in Scene Kit as is, it's going to look upside down. It's because the origin is flipped. So that's why this convert point method here will take will allow you to convert back and forth between the two coordinate systems. Okay, so I just wanted to give you a heads up there. If you're looking at the code after this this session, then hopefully it'll make sense to you. So that's scene, SK scene. There's SK view. An SK view is basically the view that renders the scene. And then what's the most important for us is this SK Sprite node. So this is what we're going to use to render our planes. And in fact, we'll probably use this to render these beacons also. Because what we want to do is we want to know when the plane has reached the beacon. So if the beacon and the plane are both sprite nodes, then if the plane touches the beacon, then we know that that plane has reached that beacon. Okay. So you can see here some methods. Texture is an SK texture. That's basically how we tell SK Sprite node how it looks. So we can create a texture with an image, and then that's how we can make this Sprite node look like a plane. And there's things like size, scaling, yeah, bunch of other stuff. I didn't bring up the page here, but there's something called an SK action. So an SK action is something that we can tie to a Sprite node, and it will animate the Sprite node. So the action could be a movement. So I can give the Sprite node an action that says move this way. So either follow this path or move in this direction at this velocity. Or the action could be something like, I want to animate your opacity. So I want you to fade in and fade out, for example. So that's called an SK action. So yeah, so that's kind of a quick overview so that you'll understand the code as we jump into it. All right.
So I don't think you actually mentioned what is a sprite. I don't think anyone answered.
Oh yes, no one answered. That's right. Okay, okay. Do you want to tell them what a sprite is, Adrian?
Sure. Yeah. So it's basically just a 2D image that generally would move within some sort of scene, so an animation with an image. So I mean, when you're talking about two-dimensional games, it's sort of a classic way of showing things moving on the screen.
Yeah, that's right. So like if you've played like Super Mario, like Mario would be a sprite. He can jump up, he can walk around, even, yeah. So anything that can kind of independently move on its own, is most likely a sprite. And then they can interact with other sprites on the screen. Yeah. Okay. Thanks for catching that, Adrian.
Sure.
Okay, so if there are no other questions, I guess we can move to the next part of tonight's podcast, where we're going to go over some of the code that we went through with the Sprite code. So, yeah, thanks, Adrian. I don't know if you still have time to hang around with us, but if not, you're free to go. But if you do have time, then we'd love for you to stay.
Sure. Yeah, I'll stick around.
Okay, great. So. Just give me 1 second. I'm going to switch screens here so you can see my Mac screen. Just give me 1 second. Switch to my Mac screen. All right. And then I'll put myself in the corner. All right. Okay, great. So what I'm going to do is similar to last week. I've already pre-coded some of this stuff. And so you can see here I have a number of commits. I'm going to jump from one commit to the other. So last week we ended up here. Demo 02. So this is what the code that we sent out. This is where we ended up. So I've put in a few other commits up till today. And today you can download demo03 from the GitHub link. But what we'll do is, what we've done is we've converted to use Sprite Kit. So that's the first thing we mentioned earlier, right? So from using UI buttons and other UI kit components to actually using Sprite Kit components. So I've jumped to this commit here and I'll show you what we've done. Okay. So you'll see here we have a number of new classes. This class here is called the plain node. So let's look at this code. We won't go through it line by line, but we'll explain what it is. So this plain node is a sprite node, an SK sprite node. So as you can tell from the name, this represents a plane in our game board. I'm going to skip this for now. I will come back to it in a bit. So you can see when we create a plain node, we give it a texture. So they all start off with an image called an airplane. And if you recall from last week, our airplane image looks like this. It's just a white plane with a black border. And as I said, before we finish this game, we'll hopefully be able to upgrade these images to something that looks better. We also have another image called an airplane black. And we've been using this last week to show that the plane was selected. So you can tap on a plane. And we called it last week, we're entering into the trace path mode. So basically, when you've selected a plane, then you can start tracing the path for that plane. And then when you finish tracing the path for that plane, then we exit the trace path mode and it goes back to the normal mode, which is this plane. Okay. And then I've added a third one. This is a red plane. So as you can probably imagine, this is to indicate that the planes have collided. Okay. So if you go back into our plane node, you'll see that when we first create it, it's created using the default just airplane image. Okay. Okay, and then this is the interesting part here. So last week we used UI buttons, and then we added images to the UI buttons. And the UI buttons automatically know how to detect when they've been tapped, because that's what a button is for, right? But these sprites don't normally do that. So what we've done is we've overridden these methods called touches began, touches moved, and touches ended. So we're basically implementing what UI button gives to us. So touches began means the user's finger has touched the screen. Touches moved means that without lifting their finger, they've moved their finger to another spot. And touches ended means that they've lifted their finger off of the screen. So what we've done here is we're creating our own events, a touch down, a touched up inside, and a touched up outside. So touch up inside means that you've touched the plane, and then you've lifted your finger while your finger was still in the plane. Touched up outside means you've touched the plane, but then you moved your finger outside of the plane before you lifted your finger up. So what I want to do is I'm interested in this, right? Because this would basically simulate a tap, right? When you tap a plane, then you touch the plane and you lift your finger up without moving your finger too much, right? So this touch up inside is what I want. And what I've done then is I've called these three delegate methods here. So you'll see up here that we have a protocol, and anyone who's interested in knowing about these events would establish itself as a delegate of this object, and then we can then inform him when any one of these three events have occurred. Okay, so that's basically what the plain node is. Any questions from the audience, please, or something is not clear, please feel free to post a question, and you can ask, and I can stop and explain. Okay, so that's the plain node. And then we have the game scene. So remember, we looked at the documentation. The game scene is a subclass of SK scene. And this is, I guess, one of the core objects or classes that we need to take care of. You'll notice here I've created a new method called spawn new plane. And And then here we've overridden this here, did move to. Remember in the documentation, this is part of the lifecycle methods for an SK scene. So did move to is called when this scene is first loaded up into an SK view. So this is kind of analogous to a view did appear in iOS. Okay. Or view did, maybe view did load. It might be more analogous to a view did load. So here I'm just setting up some parameters. And here I set up this flags here that shows us the FPS count. Okay. And then we have a utility method here just to create a random start position. So basically we will call this so that when we spawn a new plane, it'll just spawn randomly on the screen. Now later on, we're going to change this because we want to be able to spawn planes coming out of the beacons. But right now, just for our testing, we're just randomly creating the plane somewhere on the screen. Okay, and then finally, we go back to our game board view controller. So there's quite a few changes here. But we still have the trace path view from last week, and we still have the paths view. If you recall, the trace path view is where the user is able to draw the path for a plane, and the paths view is where the plane views actually reside. Oh no, sorry. The paths view is where we redraw the path. So the trace path view is where the user is drawing the path, and then after they've drawn the path, we take that and we trace it back out here. And then the Sprite Kit view is where the planes live. Okay, so let's run this and let's see what we have so far. Okay, so you'll notice I've changed the font to make it look a little bit more game, more, I guess, I don't know what you call this. It's some sort of crayon type of look. And I've changed the color to purple too, so it's not just the default blue. Okay, so let's spawn a plane. So the plane spawned here. So we can select the plane, and now it turns black. So when it's black, that means we're in the trace path mode. So I can trace a path. Then when I let go, you can see that it takes that black path and it redraws it onto the paths view. And then the plane is now animating onto that path. Now, if you remember last week, we had to animate the UI button ourselves, right? We had to calculate where to move the UI button at every point. And we implemented a game loop where every second we would move the plane to where its new position would be. But this time, we didn't do that. I'll show you now. We'll go back to the plane node here. We now have this new method called set motion. And what I'm doing is I'm giving it a Bezier path. And you'll see the first thing it does here, this section, is it actually converts that Bezier path from one coordinate system to another coordinate system. Okay, so this Bezier path here is from the UIKit coordinate system. So we're converting every single point in that Bezier path into an array of transform points. So these are points now in our new coordinate path. And then we're taking that and those new points and creating a new Bezier path called transform Bezier path. And this is the one that lives inside our coordinate space. Okay, so after that, we create an SK action. So remember, an SK action is how we animate items in Sprite Kit. And we're telling this action, we're basically going to follow the path of the Bezier path. And we want the Sprite Kit to automatically orient our plane. Remember last week in our code, we actually had to rotate our button so that it's always facing the direction that it's moving. Now we don't have to do that because it's all done for us. We just say orient path to path equals to true. And then we gave it a speed of 20. And then we just say run this move action. And that move action is basically responsible for this animation here. Okay, so this animation here following this path, I didn't put any additional code other than what I just showed you here. So you can see Spritekit buys us quite a lot of things. Okay, So any thoughts from the audience? How you think this compares to how we did it last week with UI Kit? Let us know in the chat. Okay. So now let's jump on to the next commit. So the next commit I want to show you is, let's see. Let's jump to this commit here. So D4 FE 784. Okay, so what I've done here is now I've added a path fade out. So let's show you how it looks. So remember in the previous iteration, after I drew the path remains on screen for the entire duration. So what I've done now is that you see the path turns gray and then it fades out. So you see where you drew the path, but then after a while it fades out. So but the plane still continues onto that path, but we don't clutter up the game screen with all these paths. Imagine if we had other planes here, and you draw paths for them, then you'll pretty soon have lots of paths on the screen. So I thought, let's fade it out, and then we have a cleaner screen. Oh, we have a comment from Adrian Chen. It looks really nice. Oh, are you talking about removing the path? It cleans it up. Okay, so while Adrian is letting us know. Okay, Adrian says, yeah. Okay, awesome. Thanks, Adrian. So, yeah, you see the plane's still moving. Let me show you some problems of what we have so far. Okay, let me just reset the board. We have a number of problems. Okay, number one, you see the plane starts off not moving. That's not realistic, right? Planes don't start off as not moving, so that needs to be fixed. Second, let's draw a short path. You see the plane moves onto this short path, and then when it gets to the end of the path, it just stops there. That can't happen too, right? So in real life, I guess if I'm the air traffic controller and I told the plane to only go this far, once it gets there, presumably the plane should still continue in that direction, right? Because I haven't given it any more instructions. It should continue in that direction until I give it new instructions. So that's one problem. The other problem is, okay, take a look at this. So I select that plane, but instead of drawing the path from the plane, what if I drew a path here? And then if I let go, the plane just magically transports up there, right? So that's not very realistic too, right? I select the plane and I start drawing the path here. When I let go, the plane just transports there. Okay, so that's not good either. So that needs to be fixed. Let's see. Okay, I've spawned a second plane. So I can move that plane and I can move this plane. So we don't have any collision code yet. So if these two meet right now, what happens? Yeah, they just go right through each other, right? So that's something that we can add today too. Okay, but the problem with the plane stopping right here, that's something that we can fix. Okay, so let's see if we, do I have that in my next commit? Yeah, so I'm calling this a free flight mode. So basically, the plane will keep following my instructions until it gets to the end of my instructions. And then at that point, it just goes into free flight because, because I haven't given it any more instructions. Okay, actually, before we do that, let me show you the fade out, just so you can see that. We go into, where's that? Let me try to find it. So, okay, here we go. So here's where we draw the plane path, right? So the user has traced out the path. Now we're drawing it here. We're drawing it as a dark gray color. So we're adding it as a sublayer in our paths view. And then after we've done that, I created one animation here, and we're animating on the opacity property of this path. So opacity is how transparent it is. So it's going to start from 1, which is fully non-transparent, and it's going to go to 0, which is fully invisible. And it's going to animate over 1 second. Okay, so I'm adding that animation here. So that's what happens when I draw the path. So it's going to animate from visible to invisible in a span of 1 second. Okay, so that's that code. All right, so let's jump to the next commit here, add free flight mode. So git checkout 97642D2. All right. Okay, so let's run that and let's see how it works. Okay, so I've just spawned a new plane. I'm just going to give it a short path, and then let's see what happens when it gets to the end of that path. Okay, so you see it keeps going in its last direction, and it'll just keep going that way, right? So that's what we want. So if we didn't give it any more instructions, it'll just fly off screen, and then that's it, game over, right? Because that's not where he was supposed to be to go. But because we didn't give him the right instructions, then so let's do that again. So I can give it a path like this, and it should continue flying based on its last direction. Okay, great. Okay, so let me show you that code. So I added that code here in the set motion. So what we had before was this, right? So what I've done here is I've created a new mode called in free flight. So in free flight, basically what it does is it tells the Sprite Kit to have the plane follow this path. And then once it's finished following that path, so once it's finished, this action is completed, it's going to execute this portion of the code. So at the end of this action, it's doing some math here. It's basically calculating the heading. Okay, so the tangent angle, and then using some geometry. You can look this up if you remember from your geometry classes. And basically, we come up with a vector, and we tell the physics engine that we want to continue on this vector, basically this direction. So this direction is where the plane was flying last at the end of its action. So we want to continue on in that direction. Okay, and so we're setting the velocity of the physics body in that heading. So yeah, so that's what this does. Okay, you'll notice too that I've done something here. Before we do the action, we remove all actions, and the reason for that is because let me run this again. So we have a plane here. I'm going to draw a really long path. Okay, so a really long path. Okay, so now the plane is this whole path is one action. But I can tap on this plane and I can give it a new action. Okay, when I give it a new action, I want it to cancel the previous action, right? So that's what this remove all actions does. If it's still in the middle of an action when I give it a new action, then I want it to cancel the old action by removing all actions and then give it a new action. Because otherwise, if I don't remove the old action, then the system will still try to complete the old action on top of this new action that I've given. Okay. And let's see, did we fix this? Does it still transport? Okay. There's one other thing that I've added here too. You'll notice that if I select the plane and I give it a path that starts here, rather than teleporting to that place, it will actually fly to that place first, and then it will start that path. So that makes a little bit more sense, right? It can't teleport, so it needs to take time to get to where I drew the path, and then it'll go on to that path. Okay, so I can spawn another plane here, give it a path, and then it won't teleport, it'll just fly to that path. All right. And I don't think I have collision here yet. So they're just going to go right through each other. Okay. So you saw that they bumped across each other. So that physics is now working in that they actually have a physical body, but we didn't do anything. So they just kind of tried to push each other out of the way. Okay. And so that's the last thing that we will show you is adding the collision behavior here. So git check out demo 03. Okay, so what I've done is I've added the collision behavior. So now let's see that in action. Okay. Oh, that's one thing that we have to fix too. You see, I spawned it and it's already half off the screen. So, but I guess we don't have to fix that now because eventually we're going to have them spawn out of a beacon. And what I want to do is when they spawn out of a beacon, I want them to come into the screen and they're already moving. They can't be just static like this, right? Okay, so let me select that plane. We'll give him a path. We'll spawn another plane, and then we'll have them both collide. Okay, so you see that the collision was detected. They both stopped. Presumably, we should have some sort of maybe explosion graphic that kind of looks nice, right? But for now, they just kind of stopped, and they both turned red. Okay, so let me show you how that's done. Where is that? Okay, that's here in this method, did begin contact. Okay, so the game scene is able to detect contacts between the sprites. So it passes us this object called a physics contact. So this physics contact contains two nodes, body A and body B. So I'm checking to make sure that both bodies are planes. So I'm assigning one to first plane and second plane. And then I'm calling my delegate and telling them that in this game scene, plane A and plane B has collided. Okay, so let's take a look at that. So that's here in the game board. And it's right here. So did collide. So the first thing we do is we pause the game. So game scene.view is paused. That's why you can see that they've stopped moving because I've paused it. Otherwise, if I don't pause it, they're going to try to, they're going to try to push each other out of the way. They'll bounce off each other. They'll try to push each other. But since this game, the game has ended because they've collided, then I just pause the animation. And then what I do is I set both plane view models to is collided. And if we look at the is collided here, what I'm doing is I'm setting their texture to the airplane red. Okay, so I'm setting both of those planes to be red, and then that's it. That's the game over. So there's additional stuff that should be added to this. We should put up a message that says game over. We should have a scoreboard somewhere, so that scoreboard would stop. And however many planes we've successfully guided, that's our final score. So yeah, so that's kind of what we got so far this week. Any thoughts or questions? Adrian, can I bring you back?
Yep.
Okay, let me bring you back. So any thoughts or questions from the audience? How about you, Adrian? I don't know if you were following all along, but any thoughts on what we have so far?
Yeah, definitely making progress, and it seems a lot more straightforward with using the Sprite Kit stuff.
Yeah,
I'd never actually seen Sprite Kit used before like this, so it was kind of a good introduction for me as well.
Okay.
Yeah.
Yeah, I mean it's pretty rudimentary. Okay.
Yeah.
Adrian says no, so no questions from Adrian. William says looks good. Okay, awesome. Thanks both. Yeah, I mean it's pretty rudimentary so far. Sprite Kit is actually very powerful. Like if you guys have a chance to play around with it, there's gravity. The gravity is pretty cool, right? Because because you can actually apply a force, so you can apply either a continuous force on an object or just an impulse, which is just a momentary force. So So if, let's say, you were modeling a helicopter, the gravity would always be trying to pull it down. But then if you have an equal opposite force that's pushing the helicopter up, then you can make it hover. So things like that is like you have your own little physics world that you can kind of play around with. If you have like a cannon, then you can impart a momentary force. It's called an impulse to the cannonball. So then it would go up until, that force dissipates and it's going to come down. So yeah, it's pretty cool to play around with like your own universe. Yeah.
Is Spritekit used a lot by people in industry building iOS games?
I think just for simple games, because it's not as full featured as, let's say, Unity or what's the other one? Unreal, right?
Yeah.
Those are the two main ones. So it's not as full featured, but for simple games, I think people, you can do quite a bit with it. You can have things like particle generators. So like if you have, if like say you have a missile or something, and then you have the fire coming out behind, so you have particle generators. You can have things like joints where, so you can have two objects that are joined together. So when you move one, it'll drag the other, but then it drags it around in the physics world, right? So there's like some type of inertia, some type of momentum that's kind of, built in. So you can grab one, and that joint could be elastic or it could be rigid. So if it's elastic, then this first one, you would pull it, and then eventually, it would kind of yank this over. So some pretty cool stuff that they've modeled. But yeah, it's still not as full featured like as a full game development environment.
Mm-hmm. Yeah. I mean, it seems like with what you have in the repo there, even for some of the students, like it would be a good place to just start out and start tweaking stuff and playing around with Spritekit, see what you can actually do.
Yeah, that's right. So yeah, so students, what Adrian said is pretty cool. I did that a lot when I first started learning programming too. I just take other people's code and just start modifying little things here and there. What would happen if I did this, right? So instead of writing everything from scratch, I base it off an existing code base and then just play around with that. So yeah, perfect. That's a good suggestion. Okay, so if there are no other questions, then I guess, I didn't, I forgot to post the URLs, but if you were with us the last few times, then the GitHub URL is the same. So the demo 03 is already pushed out there. And an open invitation, if you're just joining us or if you haven't requested to be part of the beta testing yet, what you can do is send me an email. So my email is roland@gameofapps.org. So ROLAND. Actually, here, let me write it down. Okay. So this is my email address. So roland@gameofapps.org. So if you have an iOS device, iPhone or iPad, and you want to be able to install this as part of the beta test, just send me an email with your Apple ID and I'll invite you to be part of our beta tester group. And then you have to download TestFlight from the App Store. That's an app from Apple. And using TestFlight, you can install our weekly builds onto your iOS device. So make a note of that. And then if you want to go to GitHub, I don't remember what the URL is, but I think it should be under GitHub Game of Apps. I can't remember. I'll post it onto the comments. Then you can get it there too. All right. So I guess if there are no other questions, then that's it for this week. Any final thoughts, Adrian?
Nothing too much other than, take a look at that repo and have some fun coding.
Yeah, awesome. Well, thanks so much, Adrian, for joining us. I really appreciate you joining us this evening. And thanks everyone in the audience. Hopefully you found it useful this week. And please stay connected. Use the comments on the YouTube video to post any questions you might have. We'd love to hear from you, and we do check that. Otherwise, have a good week, and yeah, we'll look forward to seeing you next time. Okay, take care.
Bye.
Bye bye.